Hello guys, so as you see we are underwater, maybe too much underwater, but for now I'm about to deliver the git file and the execute file on the Dropbox so everybody can see and use it because people complain about compilation and they know how to do this. So this is playing Game Maker Studio in one of the current runtimes, and I'm about to show how it works generally, editor and stuff. It is not in the full use. I have cut some function and I show how to start it with this speed on the potato by using different cores, which we have a configurator for batfiles for the people that don't know how to choose the core in the Windows model, and later on I gonna show how to start it. So I mostly tested this. This is not the original. We can use the autofiller, yeah, and then we have to copy and paste executive file, so it will be added here, there, and there. And probably in the file you're gonna have, you need to remove those marks. I gonna fix it on the later versions, as I have found it doesn't work on Windows with this with those marks. So but I gonna also show the file when it works. So it will be something like that. This is auto file. This must be pasted because otherwise I need to save file name somewhere in the game. Later on I gonna forget it, and yeah. And here we're choosing which core we want to run on. I made only 5 choices because I have 6 cores. And it is not possible on the current version to run multi-core, so plain Game Maker Studio gonna work on one core only. There is no choosing more how it streams, more streams for multi-core usage. I know how to go around on the plain Game Maker Studio about it. I have idea how to use it. However, without using any C or some other infused code to split memory and semaphores and stuff, but it is not the issue that I'm about to solve now. So yeah, so if somebody don't know how to create a bat file to execute on Windows on different cores than 0 and his games are slow or something, so this is general file. I'm gonna show it soon. Let's say I stop speaking now and there will be file here now somewhere shown. Okay, like that. And if someone don't know how to do such stuff, there will be more description about it. So now we are right click to remove the fake right clicks, these messages that shows up. So now we are inside the water. In editor I'm gonna show how it works, what it is, and so on. So this is just a mask. Of course there is nothing in the sky, so it is skipping rendering, nothing happens because sky is 0 distance from camera for now when it's empty. So we're gonna have artifacts in the places where there is no continuity in terrain, like here, yeah, the holes and stuff. So we are now over the water, yeah, like we have a terrain and the whole map with all the shaders and stuff. As you see, it works quite fast because we are not using logic for our guy to run around, or more guys. And here are some gravity fields. They are currently invisible because I excluded them in the shader in the order of drawing. I have idea how to mark them in gameplay on different way than in editor. So they're gonna show up. So as you see, there is nothing underwater. We have only flat tessellated vertex buffer. It is generated automatically. So this is not a vertex buffer that you need to load. It is generated from pieces. And same, not same. It is 1, 2, 3, 9, 10, 10 vertices on every piece. So this middle vertices is up and down. Difference is 0 between them, but it shows up 2 triangles down and two triangles up. So we have something like surface from the top and from the bottom. You can rotate this water against the gravity on whatever way you like, and it's gonna work same way, because for now water is detected by camera. It can be detected same way by character, but I need to write some logic for swimming and similar stuff, but it is for later on when I go to the animation editor. So as you see, we have here some artifacts that are made by purpose. It is 3 lines of code that makes those bricks. And if we go under the water, you see small blue dots. There are same type of artifacts made similar way. They are showing all around. And I'm not sure if I'm gonna keep them. Maybe they're annoying or something is wrong. I don't know. It is 3 extra lines of code just to make them. So I don't know if I keep them. Okay, now we see things under the water. The render works on calculating the depth. So if we rotate water and put it sideways from the edge of the water to the depth will be calculated correctly. So it is free rotating water, whatever we do, and the max depth for now, just because how I put the magic numbers in editor, is 1000. And the calculation works the way that on 1024 the water will be completely dark. For now it is not darkening, not much by the depth, because we are not deep enough, and the water ends here, yeah, as you see. I left this in editor so I can see where I put the vertex buffer, but this bottom path gonna be erased later on. So as you see, if we go to the water, we are inside the water now with camera. The things are blurred differently, like more deeper we go, the more blur is added proportionally, and the deeper we go, the darker it will be. So if we put water upside down, darker it will be also if we go up. So it is how it is calculated. More or less it is far more complicated. And then we have some blur and stuff. If we go near the stuff, near the things, so all what we see here works that this vertex buffer consists surface up and surface down. This is the same vertex buffer. They have different UV paths. So from the top it is left top quarter, and from the bottom it is right up quarter, or something like that. Yeah, there is a calculation in the shader. And if we go inside the water with the camera, before the camera, if we go near enough, the whole camera is screened with vertex buffer of two triangles in the front of camera on distance 11, because we have clipping plane on 10, with the screen. Now it is screen. Yeah. Let's rotate us. That is clipped to the volume of the water. So if we go somewhere on the edges of the water, we're gonna see this clipping, like here. Okay, now we see. You see, this is not in the water completely, yeah? Now we are in the water, now we are on the edge. The edge is directly here. Yeah, I know it's extended a bit here, but generally it is how it works. So the vertex buffer on top is extended by 12.5 units. Yeah. Of course, I don't expect anybody gonna make the water inside of nothing like here. It will be constrained with terrain, so logically we gonna have something reasonable. It is why there is no sides on the water. So let's say we go under the water, and our camera is screened, and we see everything blurred by the water shader, and where the water shader of the surface material 23 is visible, so the water shader of underwater is suppressed a bit, yes, or more, I don't remember. I think it is suppressed completely, and if we have something in between, so water, this surface that there is drawn, the surface of the water, so on the surface in the video memory, this surface is suppressed. It is called invalid. They are drawn separately from the whole depth buffer, so not completely, but depth buffer deliver only the distance from camera. So this is drawn with the underwater shader, and this pixel is drawn with the surface shader. Otherwise it will looks differently, and clipping plane is 10, so if you go near enough, this is without water shader, yeah? You see how it moves? The water shader is on distance 11, and we have clipping plane on 10. So obviously we see this, but later on there will be excluded by different things, because if we go near to the wall, yeah, like it looks wrong, it looks stupid, yeah. So it should be excluded, and this is thing to make it later on. So the water wall looks that way, and deeper we go, more blurry it will be. So if we see from the top, yeah, like we see what is going on under the water, but it is hard to tell the distance. And if we go deep, things are blurry. Of course, if we go near, the blurry is smaller and smaller, but it doesn't go away completely. So near we go, more we see. And another thing, if we move the camera, blur is bigger, because it is taking a difference in XYZ position of every pixel, because every pixel here have a XYZ position. So it works that way. If you want to see the surfaces we are using,